Welcome to part 3 of this series. In this video, we will continue to practice the skills we have learned from the previous videos through 7 worked examples. Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. Welcome to the third session of this quadratic equation topic. The first question here is based on the information of both alpha and beta are the two roots of this quadratic equation. X squared plus x minus 2 equals 0. Then it asks us to find the value of alpha minus 1 times beta minus 1. One approach for this problem is to expand this expression of alpha minus 1 times beta minus 1 and then apply via the theorem to obtain the result. The alternative approach is to factorize the quadratic equation and find the two roots, then substitute them into the expression to get the results. For the first approach, after expanding the expression of alpha minus 1 times beta minus 1, it becomes alpha times beta minus the sum of alpha plus beta plus 1. As we know from the given quadratic equation, alpha times beta equals negative 2, while alpha plus beta equals negative 1. So the expression of alpha minus 1 times beta minus 1 equals 0. As for the alternative approach, the cross product method is used here to factorize the equation, and the two pairs of roots are obtained in this way. However, we find either pair of the roots produces 0 result after substituting them into the expression of alpha minus 1 times beta minus 1. In summary, the expression has the value of 0. Question 2 is a quadratic equation with parameters a, b, and k. The question is to find k in terms of a and b, given the criterion that the equation has repeated roots. Since the equation has repeated roots, its discriminant must be 0 in this case. So delta equals 2k plus 2a, or in parentheses squared, minus 4k times the sum of k and b equals 0, which relates to the equation of 2ak plus a squared minus bk equals 0. Hence, we find that k equals a squared over the result of b minus 2a. Question 3 is also a quadratic equation containing parameter p. The question here is to find the value range of the parameter p, given the criterion that the equation has repeated roots. Since the equation has real roots, its discriminant must be greater than or equal to 0. So the inequality is established, which is 2p in parentheses squared minus 4 times the sum of p and 1 times the sum of p and 2 greater than or equal to 0. Finally, we find that p is less than or equal to negative 2/3. Question 4 has two quadratic equations to solve. For the first one, we rearrange the equation and transform it to its standard form by moving all the terms to the left-hand side of the equation, and then combine the like terms. Initial inspection tells us that the equation cannot be factorized using the cross product method, so we will try the completing square method and the quadratic formula method to solve this equation. For the completing square method, the quadratic coefficient 3 is taken out in order to make the quadratic coefficient as 1. The next step is to find a constant together with x squared minus 6x, the two terms, to form a complete square. As we learned before, the constant is equal to half of the linear coefficient and then squared. In this case, it is just 9. After making the completing square and combining the remaining constant terms, we have a form of the difference of two squares. The roots of this equation can be obtained by factorizing them and by applying the new vector law. Now, let's try to use the quadratic formula method. The first step for this approach is to calculate and check the discriminant of this equation, which equals 18 squared minus 4 times 3 times negative 2, which is 348. So this equation has two distinctive roots according to the quadratic equation formula. x1 and x2 can be obtained by substituting the corresponding coefficients into the formula. They are equal to 3 minus square root 87 over 3 or 3 plus square root 87 over 3. As for the second question, it needs to be rearranged by moving the number 2 to the left hand side of the equation and then combine the two terms into one single fraction. As we know, if the fraction equals 0, then its numerator equals 0. So we have a quadratic equation with its standard form to solve now, which is x squared minus 6x plus 3 equals 0. The first approach here is to use the completing square method. As explained earlier, we need a constant term, 9, together with the terms of x squared minus 6x to form a complete square, and then simplify the remaining constant terms. Now we have a form of the difference of two squares, x minus 3, or in parentheses squared, minus square root 6 squared. After factorizing and applying the new vector law, we obtained the two solutions for this equation, 3 minus square root 6 or 3 plus square root 6. As for the quadratic method, formula method, we need to calculate and check its discriminant first. Since delta is equal to 24, we know the equation has two distinct real roots. After applying the quadratic formula, we have two real roots, 3 minus square root 6 or 3 plus square root 6. Question 5 shows the quadratic equation with the parameter m as its constant term. It asks us to find the value range of this m given the criterion that the equation has two positive real roots. Since it says the equation has two positive real roots, we need to find the expression of roots in terms of parameter m. There are two approaches to achieve this. One is to use the quadratic formula method, and the other is to use the completing square method. Here we just use the completing square method to find the roots in terms of m. However, you may try the quadratic formula method yourself and see if you are comfortable with it. As we did earlier, for the completing square method, we need a constant to make the quadratic term x squared and the linear term negative 2x together as a complete square. This constant is calculated as a half of the linear coefficient and then squared. In this case, it is just 1. After rearranging and factorizing it, we have two roots expressed in terms of parameter m. Among them, the smaller one is 1 minus square root of the sum of 1 plus m, If this root is greater than 0, then the value range of m would satisfy the requirement of the question. Hence, we solve this inequality and find m is less than 0. Question 6 is a quadratic equation with two parameters m and n. It asks us to find the ratio of n over m given the criterion that this quadratic equation has repeated roots. Since it gives the information about the roots of this equation, we need to start with the discriminant. As we know, repeated roots means the discriminant delta is equal to 0. So we express delta in terms of m and n, which gives the relationship of m minus 4n equals 0. Therefore, the ratio of n over m is 1 over 4. Question 7 shows us a quadratic equation with an unknown m. The question is to find the roots of this equation given the criterion that x1 plus x2 equals x1 times x2. Here x1, x2 are the two roots of this equation. The first step is to rearrange the equation by moving all the terms to the left-hand side of the equation and then sort out all the terms such as quadratic, linear, and constant terms. Initial inspection may suggest us applying the theorem to this question, and maybe it is a cost-effective approach to find the value of m. As we recall the Viada theorem again, x1 plus x2 equals negative b over a, while x1 times x2 equals c over a. So we establish the equation based on that. It is the result of 7m minus 9 over 3 equals 6m over 3. So we find the value of m in this way. M is equal to 9. The next step is to substitute the value of m back into the quadratic equation. After rearranging, we have the quadratic equation in its standard form. Then we use the completing square and the quadratic formula method to solve this equation. As for the completing square method, we add a constant which can form a completing square together with the quadratic and the linear terms. After this step, we have x minus 9, or in parentheses squared, minus 63, which can be factorized using the formula of the difference of two squares. Therefore, we have the roots of this equation, which are 9 minus 3 square root 7, or 9 plus 3 square root 7. As for the approach of using the quadratic formula method, the first step is to calculate and check its discriminant, which is 36 times 7. Hence, the quadratic formula is applied to obtain the answer. Finally, we have values of x1 and x2. They are equal to 9 plus or minus 3 times square root 7. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.